All right. Well, thank you for coming to my talk. It seems like we do have a few users who know Federation in here. That makes it a little easier. But yeah, I'm going to speak a bit about module federation and beyond. So for those who don't understand or who haven't heard of federation before, what it does is it allows you to import dependencies or share code from independent compilations. If you've heard of micro frontend, or we just had a great talk from NX, where they kind of showed different ways that you can share your code. The idea with federation is you can do the same thing, but at runtime. So I would configure it like that, somewhere else in a code base, different repo, whatever your setup is, you can just import it. And all the connections, or if you share dependencies like React or something else, all of those are linked and shared at runtime. So since it's been developed, it has gained some decent traction in the larger set of companies. You can see here, definitely some recognizable logos and names. And during that growth, we realized it was time for a redesign. So the main challenges that we kind of saw were software's become more complex. And what I had initially designed it to do is not living up to the demands that the users have in modern applications. There's also new bundlers coming out, and lots of workarounds over the years that have frustrated users. So we released 2.0, and 2.0 was a major rewrite that we implemented. As you can see, the goal of it is to introduce a bundler-agnostic approach to create runtimes and SDKs, and to decouple it from Webpack. So to go over a few of the new capabilities that we rolled in here, one of the major ones is this concept of the runtime API. What the runtime API does is effectively what you could do at compile time, but you won't need a plugin to implement federation. In this example, you can kind of see it in its pure form, how we would initialize something, share or specify different modules. And again, you don't need a bundler to do this. In this scenario, I'm sharing something like React. If we look at runtime plugins, which is another feature of the new design, these work either at compile time or at your runtime. But what they let you do is actually hook into almost like express middleware, but on import. So if I say import, button from app1/button, with a runtime plugin, I would be able to intercept every part of the request lifecycle. So the import from doesn't actually mean anything. And through the runtime plugins, you can rewire your application's dependencies on the spot. These are some of the hooks, but we do have more in our docs. To give you kind of an example of what we can do with some of these runtime plugins, we have a simple example here where I'm going to go in and rewire the node modules that the application's actually using. So just from a simple UI, there's no multiple deploys or multiple builds happening here, but you can see I can change React DOM of the main application. I can change different various parts of it through just what's in the browser at that moment. Another example is if you've ever used federation, you've probably dealt with what do you do when a dependency isn't available. Something isn't online, and that usually can crash your application. So what we ended up doing was introducing something like a error load remote hook. So assuming something is not online, that hook would fire, and pretty much whatever you return is what the export, the application will receive. So in this scenario, only app 1 is online, and app 2 is not running, and the remote hook is returning a React component that just renders the error as a string. So you could put anything in there, dynamic import, a fallback from NPM, whatever you want. Another cool example that we've kind of rolled out is something like API-controlled remotes. So imagine if you wanted to control all of this from a server, from A/B testing, or AI is getting popular. So imagine the integrations there. Again, all the imports in your code base don't mean anything. They are controlled or can be controlled by a simple runtime plugin like that. So if you wanted to change out your deployment locations, perform green blues, anything like that, again, you don't have to rebuild the consuming app. This stuff is all done at runtime, so I can just swap out what header is, or which version of header, or I can roll out different variants of the application to certain regions in the world. An example is when I click on the button, I'm going to rewire the application to import. It's only called app2 button. There's no other import. But those are two different code bases, two different builds, two different releases. And when you hit the button, you can replace what app1 is at runtime. Similar kind of idea with dynamic mapping. I configure it here. I add a runtime plugin. And again, over there, I can actually wire it up to wherever I want to go. Imagine localhost development on production, or using staging servers and mixing the application together. So you don't have to run everything locally in order to work on the application. So in this scenario, you can see a really great feature that a lot of people have wanted, which is the ability to dynamically synchronize remote types. So if you use TypeScript, just by doing this in one application, again, remote one is a different repo. The build doesn't know anything about it. But if I go in and change my types here, you will see immediately type error. So I know that a lot of people have wanted this. I'm very excited to have been able to roll it out. We've gone a step further, though, with the implementation of our type syncing. Currently, this is kind of compile time. If you have an import from or something like that, we can pick it up, synchronize all the types on the fly, and there you go. But as of yesterday, we've rolled out the ability to do the same thing at runtime in the browser. So let's say you don't know what you're importing. It's too personalized. It's too custom. We usually call this dynamic remotes. When you run into those use cases, there's nothing to statically analyze. So what we've ended up adding to this system is if you were to open your browser console and just go, global federation API dot register remote, and put in a string to register one, immediately as you fire that, the browser will send something back to our server broker, and it will synchronize the types using the information derived in your browser in development, and your types will show up right away. So another nice thing we've ended up adding is the ability to hot reload and fast refresh the application. I know this has been a frustration for a while, and we have finally solved that. So you can go in here, and whatever you type, you hit save, and again, the host application will receive whatever updates we provide it immediately. We've also introduced a really cool feature. We use this quite a bit at ByteDance, but essentially we've introduced a capability to I can't read my title there. We've introduced the ability to implement runtime lock files. If any of you work with Federation, if you refresh the page several times, if you share something like React, you'll always get React that you want at whatever SymVer rules you've set, but you don't know where it's coming from. If every app has React at 18, if you refresh the page a lot, you can get any of those. So that's not great for caching and things like that. It's non-deterministic. So we ended up introducing this manifest protocol, and that manifest protocol allows us to do things like this. We deploy this to an edge server, and it's able to ingest all the JSON remotes, as we call them, and we can calculate a snapshot from it. When that snapshot is delivered to the application, that is your environment, not whatever you're deploying. When you do a deploy, technically, that doesn't really exist anymore, depending on your infrastructure. Your production environment is the calculation of that snapshot. If you want to redeploy production, you just update the database table that's yielding that, and your application is now up to date. And that's kind of the runtime plugin of how we would implement it, just to give you an example of how this works. We will make a better demo of this, or a repo that kind of showcases it. We've also introduced Chrome Dev Tools. The idea behind the Chrome tools is really just to give you a easier way to look at what's going on, to see how the application is working, to interact with it a bit, in the browser. And we've also, through this Chrome extension, are able to introduce the ability to perform fast refresh and hot module reloading in deployed environments. So if you wanted, you could, say you work on header. You can have header running on your local host, and you can go to your production URL, enable the module proxy in the Chrome tools, and every time you hit save, production will not live reload, but it will fast refresh just the element, just for you. So we've also introduced new docs, because that was needed. It's still a work in progress, but if you are interested in using it, or if you have used it already, this is a much more reliable source to get information from. So one of the things we've seen is managing distributed applications is very tricky. Where are things? What's going to break what? How do you even deploy it? How do you get the order of operations correct? And so what we ended up doing is, this is just a very quick example comparing a traditional deploy with CI compared to a deployment with federation and a system that we call Zephyr Cloud. At ByteDance, we have a very similar concept to Zephyr called vMock. So here you can see, going through the usual steps, do a commit, wait for the deploy to happen, and it's still going. And if you think about this in bigger applications, this increases the latency. And often I found when you're trying to deploy an environment, you spend a lot of time waiting. And for most of the deployments, at least that I do, to staging or testing environments, you do them many times. You don't really need all that CI stuff, like tests. I need that when I'm actually going to deploy it. So that's roughly what a normal build and deploy looks like. I mean, it's still going here, so you can see this should be pretty standard to anybody who's deployed a web app. And that's still pretty quick, though. But now, what we're going to do is we're going to flip over to what this would look like in Zephyr. So that was about a 30-second end-to-end. Now we're going to use Zephyr. I turn that on, and I run a build. And the application is deployed to production. No CI. It's already there. And let's say you wanted to change something in this deployed federated app. And it's already deployed to production again. That's your deployment. There's no CI. Now, how you control this and make it safe, that's where the kind of back-end layer of Zephyr comes into play. If you do want any artificial gates, like tests, or do the types match, or anything like that, that's what you can decide. But if the code is built, the code is already ready. It's already on a server, and you can utilize it. If you want to see how things are actually working, this is kind of a view that it starts to generate as it understands the links between individual code bases. You can control the versions of them. You can see where in your code base the interdependencies show up. Very similar to NX's graph, but imagine if this was done at runtime dynamically. We also have some other views like that. If I'm on the shell, what does the shell consume? And I can dive deeper into those nodes and so on. So at ByteDance, I said we have a system similar to this called vMock. And we've been fortunate enough to collect a lot of business data around what's the actual return on investment we've seen from, one, designing vMock, and two, rolling out module federation to the majority of the company. For context, at ByteDance, we have about 1,000 business products, 15,000 front-end engineers, about 10 to 15,000 code bases, and we need to, weekly, we deploy our applications at least 10,000 times. So that's the general scale that we're trying to work with. Some of our remotes have thousands of versions. Some of our apps are composed of hundreds of remotes. And these are the metrics that we see at our company. 60% reduction in build time, average of 6 to 10 minutes saved, and that's using Webpack, which is already not very quick. 2,500 CI hours saved per week. A really big one here is 300% increase in engineering output. Our average output across any given product was, let's say, about 20 deployments a week. We now average 76 to 80 deployments a week since we've adopted Federation and a Zephyr/VMOC control layer. 500 additional deployments per year to the product. That really adds up. And a 40% reduction in overall application size with 80% reduction in initial JS load. So if you do want to check out anything about Zephyr, you can always go to just Zephyr Cloud IO and kind of get a read on it. But let's go back a little bit. 5 months ago, we introduced RSPack and Federation support. Has anybody heard of RSPack? All right. Has anybody heard of Webpack? Okay. So RSPack is Webpack's API, one-to-one, rewritten in Rust by our infrastructure team. It's open source, it's free, it'll always be free. But it's significantly faster. And it's compatible with pretty much every plugin and loader that's been written in the last 10 years. You can see, generally, it's about 11 times faster than a Webpack compile. And it continues to get quicker. I think this was yesterday. We just shaved another 15% off of the build. Now, what's cool here is we currently don't have any cache built in. So every time you do a build in dev mode, there's no Webpack cache as of right now. So the yields we're getting on it currently are still what I kind of call very slow. But we are in the process of introducing remote caching and distributed caching. So that means if you changed a button and somebody else had built the previous version of the application and you're cold starting it, the only thing you're rebuilding is button. You're not rebuilding anything else. Every build contributes into the distributed cache, and every user can receive and send from that cache. We're also looking at distributed compilation. So the idea, again, we have very large applications. Average size is 50,000 files. So even with Rust, they're still going to take some time to compile it. And so with distributed compilations, what we're planning to do is create, it's still in planning in early phases, but it sounds like something like a client and a set of daemons. So you can wake up the client and say, use 100 servers to compile this application. And again, because of the caching layer we're introducing, we don't compile the same piece or like a monorepo certain workspaces. We can just break up parts of the graph and say, hey, just go from, random page or from carousel down and return the updated graph to the client, and the client will seal it and give you everything that you want. We have also begun to grow the family here. We started out with RSPack, and we've introduced several other tools along the way to kind of complete our infrastructure offering. And a lot of this was just closed source projects that we use every day, and we started to look at open sourcing them for the community. So the first one I've spoken a bit about is RSPack. And you can kind of see the general speed improvements that we've seen. One of the big challenges that we have at ByteDance is we need a really, really powerful compiler. When we started designing RSPack about a year ago, we first rewrote ES-build in Rust, then we started to play around with rollup written in Rust, but ultimately the APIs just could not support the business. And we ended up moving to Webpack's API as the only thing that was really strong enough to do everything the company would need. Now, the return on investment on RSPack is also nice to see. Across the board at ByteDance, we've seen an 80% reduction in our cloud costs. That's significant, considering the amount of deployments we do every day and the number of projects that we have. We also have seen 27 minutes average savings on our builds, and that equates to about 200 hours a day per project in CI time. And from our developers' standpoint, this also relates to about 7 hours a week per developer in engineering time saved. So another client, or another user, So another user that we came across reported to us that when they moved from their current build system over to RSPack, they got a $32 million a year savings on their engineering costs. Time is money, right? And if we look at another one, 50% savings in bandwidth. And according to that report, that 50% savings, they worked it out to being in the millions of dollars in reduction to cloud costs on delivering the JavaScript assets from the CDN. We also have some other tools we built along the way, like RS Doctor, which is like a Webpack analyzer on steroids. It can show you your overall viewpoints, what your app is doing, the sizes, any potential warnings in there, drift, compile times. You can also dive deeper into views like the files, where the bloat comes from, the module counts on them, your HTML, duplications, anything like that that you'd want to know. We can also do tree shaking analysis, so you can actually see what is not getting shaken out of the build and where. Another very useful one, if you do have a slow build, you can see the actual timings of every plugin or loader in your build. This also works for Webpack, so if you're a Webpack user, feel free to install it as well. And another really nice one here is we can also see loader times. You can get very technical and low level, like how long does it take to resolve every file in your code base, or what types, The remote isn't great on this thing. All right. Resolvers analysis, and then you could also see a flame chart of your compilation time, what's adding onto it, what's slowing it down. We've also been working on our own web framework, supports server-side rendering, generally what you would expect from a meta framework, but it has first-class support for federation built in. Since we are the largest user of federation, we obviously want all the bells and whistles, plus distributed systems, and still the same kind of efficiency you would expect. We have something called RS Press, which pretty much every doc site that you see from us, it's all RS Press based, fast, simple, MDX supported, translations, other things you'd kind of expect from it, just on our tool chain. So looking at a bit of a roadmap here, we do have some cool things in the works. A big one is RSlib. So we've been working with the Webpack Foundation and a few other contributors on designing the compiler to be able to output good tree-shakeable code for NPM package development. So RSlib is harnessing these new APIs that we've added into RSPack, and it will give you, the closest thing I can describe to it is a meta framework for package authoring rather than last mile authoring, which is something I've always felt very frustrating to deal with. Dealing with types, dealing with the exports on Node, getting the ordering right. Everything else is just a frustrating experience. The one thing I've been most frustrated with in the build ecosystem is when I want to build an NPM package, I need something like rollup usually. But rollup isn't necessarily the best for that last mile compilation. So I have to maintain multiple tool chains, and that's just challenging if you've ever had to do it. So bringing RSlib in would be a nice thing to kind of complete the picture. In other news, we've also got on the federation end, rolling out import map support. I've got a PR for ESBuild support in final stages. We've seen rollup plugin with the new V2 APIs come out, and it's also nearing final support. And for Vite and Rolldown, we've already spoken to the core team, and we'll probably collaborate on integrating it in Rust on Rolldown when it's ready. For this summer, so June, July, we will be releasing V1 of RSPack, which means essentially we are passing 85 to 90% of all of Webpack's unit tests, and that's when we'll call a V1. After V1, there's some cool things happening as well, like import map support built in, multiple output targets, tree-shakeable package builds. In the federation space, we're also looking at something similar to single SPA, if you've heard of single SPA before. So single SPA was really nice because you kind of had that root capability and mount points for different frameworks, different apps. So we're introducing something we've temporarily called like the federation router. But the idea is, imagine if those runtime plugins, when you're importing code, knew about the routing system of your application. So before the app even boots, import already knows what's going on and what's going to happen. And through this mechanism, we can actually mount and run multiple frameworks as one. So let's say you have an Angular app and you have a React app. Usually you have to mount it or, do something kind of manual. You can't just import Angular as JSX and it work. But with this, you would be able to do exactly that. If you've got an Angular app, you as a React user or consumer would be importing it just like normal and using JSX just like normal. And this will operate in all the directions. So view bindings, React, Angular, and they're all kind of interchangeable. And you wouldn't know that you're not actually using a React component, and it all happens automatically for you. The other really cool thing is there's a routing bridge attached to everything. So you can have your Angular router understand where you are in the React application and take over the routing for the remaining flow if you wanted to. Things like nested routes have been very hard to discover or work with in these kind of dynamic at runtime environments. So with the multi-app router system, most of those issues should be resolved. We are also working on something called RSpeedy. This one's a little further out, but the idea behind it is we have a lot of native apps in the company, and they're mostly React native. But we ended up writing our own framework rather than using whatever React native things there are. So RSpeedy is, again, built on the Rust stack, React Native meta framework, but instead of using, I think it's called Hermes, the React Native engine. Okay, yeah, I always get the pronunciation wrong. So instead of Hermes, which is quite a large binary payload, the engine that we've designed that runs all of our native apps is about 1/3 of the size, but meets the same performance requirements and all of that of sub 15 millisecond tasks. And then lastly, for modern JS, we are almost done with it, probably in a week or so. We'll be releasing full SSR support for modern JS and module federation, along with automatic route discovery. So if you have an app shell, it can just be an empty code base you deploy once every 6 months, and every time a new team adds a new page, adds a new route, it will discover all the routes and stitch the application together for you on the spot. So that kind of covers some of what's coming up. And a lot of the metrics that I kind of showed around the dollar amounts were from what users have reported to us. And what I kind of got from that whole thing is DX makes millions, but DX saves millions, but UX will make billions. And from our calculations and metrics, what we have seen with a conservative estimate, running on this stack with RSPack running the builds and Federation running several other parts, our estimated total cost savings at my company is, again, conservative estimate, hundreds of millions of dollars a year in savings. Yeah. So anyway, that's just a general overview of what we've been working on. There's docs and links to everything, so if you do want to find out more, you can always get me on Twitter, go and read some of the docs. We love connecting with people, helping them out, and hearing cool use cases. So, thank you.